And when we were talking about functions, I was saying, look, every function can be built from the basic function via translations, rotation, all those sorts of things. So let's have a look at translating our functions. So the first simple translation is just shifting it horizontally. Basically means in the function we're replacing x with x minus h, some horizontal shift. So y equals function x minus h. And that will effectively move it left or right, or negative direction, positive direction, h units, depending on whether h is a positive number or a negative number. And if you're ever unsure, then think of it this way. It's where did I move the origin? Because 0 is always an easy number to work with. And you have a look at it and say, well, what would x minus h equals 0 give me? And that's where the origin would have moved to. Vertically, so now it's with the y. Vertical is the y values that are affected. So we replace y with y minus k. So really this is what we're doing. We had y equals function x, but now we have y minus k equals function x. We normally don't leave it like that, of course. We normally end up making y the subject and we have y equals function x plus k. But what we're really doing is substituting in y minus k for y. That's a vertical shift. X minus h for x. That's the horizontal. The x value is changing or the y value is changing. So this will move it up or down, depending again whether that's a positive or a negative number. And again, if you're unsure, you can always solve y minus k equals 0, and it will tell you. So now we see something like this. I've completed the square on our parabola to make it a little bit easier. And using the shifting idea, we'd say, oh, okay, I know it's a basic curve, y equals x squared. That's where I'm starting from. But what have I done to it? I go, well, hang on. When I see what's grouped with the x, I've got x minus 3. So I must have shifted that right 3 units. Why is it right 3 units? Well, if I solved x minus 3 equals 0, I'd get x equals 3. So that's where 0 must have moved to. So we go across there. What else have we done? Well, I've got the plus 4 there. Actually, it was y minus 4 on the other side, but we've moved it over. Well, that one's going to shift it up 4 units. And there's our new parabola. The vertex is 3, 4. And we saw that idea when we completed the square. Sure enough, that was our vertex. Okay. But we can do it to any of our basic curves. Now, something like this, I'm looking at it trying to identify what sort of basic curve it is. Here, I'm looking at the powers of x and y. They're both 2, and the coefficient's the same. Now, our basic curve was, of course, the circle. So what have we done to our basic curve? In order to do that, I need to complete the square on both the x and the y value. So I get x plus 1 squared plus y minus 2 squared equals, and we end up with 9. And my basic curve, x squared plus y squared equals 9. What have I done with it? Grouped with the x is x plus 1. So I've shifted it left 1 unit. Grouped with the y, I've got y minus 2. So I've shifted it up 2 units, and there's my circle. Okay. Again, this must be a parabola, but it's a lot easier to complete the square on x squared than 2x squared. So the first thing I'm going to do is just divide everything by 2, just to make my life a little bit easier. Now I've got x squared plus 4x plus 5 on 2. Complete the square, but then I'll multiply back out by the 2. There I've got it. Y equals 2 outside of x plus 2 squared minus 3. What have we done? There's the basic curve. Y equals x squared. What have we done to it? The coefficients of the x squared will turn out to be 2 rather than 1. And what effect does that have on our parabola? What's going to make it steeper? It'll sort of narrow in, if you like. So it makes it a little bit steeper. Now what have we done to that shape? It's grouped x plus 2, so we've shifted it left 2. And with the y value, we've moved it down, in this case, 3 units. There's a basic curve. Now this is a very basic curve I've drawn. Of course, I haven't bothered to find out the x-intercepts or the y-intercept, although the y-intercept would be very easy to find. But it's given me a rough sketch there of what that would look like. So that's shifting it left, right, up, down. What about reflection then? Reflection of curves. A vertical reflection. So if I flip something vertically, it's the x values that are changing. So I replace the x with negative x. So in other words, y equals function x becomes y equals function negative x. And that will reflect in the y-axis. Now if you want to reflect in any other line, we can combine a reflection with a translation. We could be shifting it. Effectively what we do, if I want to reflect in the line x equals a, So it's still a vertical one. I will replace x. Yes, it's still minus x because of the reflection, but to take into account the shift, 2a, not a, but 2a minus x. And let me try and explain why. There's y equals function x. If I was to just reflect it in the y-axis, there's function negative x. But if I was now going to replace with 2a minus x, I'm shifting it to 2a. The origin is going to 2a. What would make that equal to 0? X equals 2a makes that equal to 0. But have a look now at the original curve and where I've ended up, and we can see, we've ended up with a reflection in the line x equals a. So if you wanted to reflect in some other line, replace it with 2a minus x. Horizontal reflection. So if I'm flipping something horizontally, it's the y values that are changing. So now I replace y with negative y. We replace the y with the negative y, but we usually see it as y equals negative function x, but effectively that's what we've done. We replace the y with negative y. That reflects in the x-axis. If we wanted to reflect in some other horizontal line, same idea. I'll replace it with 2a minus y, and that'll combine the reflection and the translation. Let's draw a picture of that one. There's function x. If I was to reflect it, it would be minus y equals function x, which is the same as y equals minus function x. But now I'm going to shift it up. So I've replaced it, and I've ended up with 2a minus function x. And again, if you have a look, yep, sure enough, that creates a reflection in the line y equals a. But then there's reflection in the origin. If you reflect through the origin, you might not have heard it called that before, but let's look what it is. If I'm reflecting in the origin, that basically means you're reflecting in both the y-axis and the x-axis as well. So we're replacing both the x with negative x and the y with negative y. Well, basically what we're talking about is a rotation. So rotation really is a reflection, but it's like a double reflection. So rotation, 180 degrees through the origin. There's y equals function x. If I was to reflect it vertically, I've replaced the y with negative y, so I've ended up with y equals minus function x. But now if I reflect that horizontally, I'll replace the x with negative x, and we can see y equals negative function negative x. Look at the first picture. Look at the last picture. We can see effectively what we've done is we've rotated that 180 degrees through the origin. Let's try some. Y equals minus x plus 1 cubed plus 2. The basic curve I'm playing with there is the cubic. Yeah, a little bit bumpy there, but it's a cubic. Y equals x cubed. What have I done to it? The first thing I notice is there is a reflection in the x-axis, because I've got y equals minus the function. That negative sign's not grouped with the x. It must be grouped with the y. So we're reflecting in the x-axis. Now, grouped with the x plus 1, so I've shifted it left 1 unit, and then we've shifted that up 2 units. There's a rough sketch of our curve. Y equals minus 2 to the minus x. Here's the one where I've replaced in our basic curve. The basic curve is our exponential, in this case 2 to the power of x, but I've replaced both the x with a negative x and a y with the negative y. We've got the rotation. So I'm going to reflect through the origin, or rotate 180 degrees, and we have our curve. Minus 2 to the minus x. Let's have a look this way. That came from last year's paper. Parabola y equals x minus 3 squared minus 2 is reflected about the y-axis, then is reflected about the x-axis. What is the equation of the resulting parabola? So, reflection about the y-axis means y equals function x becomes y equals function negative x. X minus 3 squared minus 2 becomes y equals minus x. I'm replacing the x with negative x. Everything else is staying the same there. I'm going to make that a little bit neater, because minus x minus 3 squared would be the same as x plus 3 squared. It just looks neater having a positive x there than a negative x. It doesn't matter, I suppose. They are the same thing. It just looks a bit cleaner like that. But now we're going to reflect that about the x-axis. And now I'm replacing y with negative y. So negative y will be x plus 2 squared minus 2. Multiply everything by negative 1 so I can make y the subject. And there I have it. Y equals minus x plus 2 squared plus 2. So let's start moving our graphs around.